Alright, let us now take a look at the next KPI. ROC is a receiver operator characteristic, and AUC is area under the curve. Area under the curve will allow us to compare classifiers against each other. What we're going to do to build up the ROC is basically, you've seen that here we put the threshold to decide between obese and not obese at 0.5. But we can put this threshold anywhere between y is 0 and y is 1. So what we're going to do is we're going to variate this threshold t, and we're going to rebuild the confusion matrix for that. And then we're going to at the same time put recall against the false positive rate in this graph. So recall, remember, is true positives divided by true positives plus false negatives. Yeah, this is how many of the true positives did you get right. Yeah, so it's 5 out of 6. Okay, and then the false positive rate is false positive divided by false positive plus true negative. Don't worry about the formulas too much, just try to grasp the intuition, and this will become clear when we fill out all these matrices. So, the first confusion matrix we're going to set up is for y equals 0, meaning the threshold is at 0. When the threshold is at 0, all points will be classified as obese. So you will not predict any of them to be not obese. So they can be 0, 0. True positives we have are 6 people that are obese that will be predicted obese. So this is 6. And false positives is 4. Now if we calculate recall, is true positive divided by true positive plus false negative, then we have 6 divided by 6, and the false positive rate is going to be 4 divided by 4 plus 0 is also 4, so this will be 1 and 1, and this is the first point of in our graph. Okay. What we're going to do now is we're going to lift the threshold up a little bit so that these two green points are suddenly classified correctly. Okay? So this is this scenario. So everything on the right of these two greens will be predicted obese. Yeah? So how many how many true positives we have? Well, still these 6 red ones, right? How many true negatives we have? These are these fellows now. We have 2. Yeah? How many false positives we have? False positives mean we predict obese and they're actually not obese. These are these 2 green ones here. Yeah? And by definition this must be 0 because the total should be 10. So the recall here is that divided by that plus that. 6 divided by 6 is 1. And the false positive rate is going to be 2 divided by 2 plus 2 is 2 out of 4. And is actually 1/2. Yeah, so once we take these 2 points in, your recall will still be 1, but your false positive rate will become half. So that's half here. Yeah, and the recall will still be 1. Okay. Now let's take the next person in, which is the red one here, right? So everything on this side is classified as obese. So we have 5 correct ones, true positives. Yeah, we have 5. So who are the not obese on this side? The true negatives are still 2. Yeah, these 2 fellows here. Now how many did we predict obese and they're actually not obese? Still these 2 green ones. So predict obese and actually not obese And that means that the red one here, we predict not obese, but the person is obese, so this becomes a 1. Your recall is 5 divided by 5 plus 1 is 6. 5 out of 6. And your false positive rate is 2 divided by 4 is still 0.5. Yeah? We have about 80% here, 0.5. We're gonna put the point here. Okay? Okay, let's now move the threshold further up. And we take the green one in. But if we take the green one in, we're basically in this scenario. So here we have already the confusion matrix. Is 3, 1, 1, 5. And you see the recall will not change, it will be 5 out of 6. But the false positive rate will change. It will be 1 divided by 1 plus 3 is 1 out of 4. So it's 0.25. So this is going to be half, but the recall will not change. So it's going to be something like this. Okay, so now let's take the red one in. Yeah, so we move higher and we take the red one. The number of true positives is going to be 4. 4 true positives. True negatives is still 3. 3 green ones. Now what are the false positives? Is 1. And the false negatives in case will be the 2 red ones. Yeah? So it's 2. Recall is 4 divided by 6. Yeah? 4 divided by 6. And the false positive rate is 1 divided by 4 is 25. 0.25. Okay? So this does not change, but 4 out of 6, this will drop a little bit. Okay? Okay, let's keep moving, and now we take the green one in here. The last green one we take in. So we still have 4 true positives. Now you have, because the green one is now classified as non-obese, you have 4 true negatives. Yeah? And the 2 red ones will still be false negatives. So this is 0, and this is 2. Okay. So recall in this case is 4 divided by 6 does not change. Recall 4 divided by 6. False positive rate is going to be 0. Okay, next we take this red one in. Yeah, this means that this will be obese, so true positives are 3. True negatives still 4 in this case. How many false positives? None. No false positives, but how many false negatives? Well, 3. Yeah, these 3 red ones, false negatives. So recall is 3 divided by 3 plus 3 is 0.5. And the false positive rate is still 0. Yeah. So recall here goes to 0.5. Okay. Now when we can actually go completely to the right and decide that all are not obese. So we predict all not obese. Yeah, so everything on the obese side is 0. This will be 0 and this will be 0. We will have 6 false negatives and we will have 4 true negatives. Yeah. So here recall is 0 and false positive rate is 0. So basically we're gonna move to this point. And our curve is like this. Yeah, this is the ROC curve. Okay, now what does this ROC curve tell you? Well, remember the cancer story. We don't want to face the case where you predict somebody has no cancer and the person actually has cancer. You don't want such a situation. If you don't want such a situation, meaning false negative should be 0, that means your recall should be 1. Yeah? So this means that you need to play in this area. You see, if you want to reduce the false positive rate further than 0.5, you will give in on recall. Yeah? And this is the type of information you can see from this graph. Yeah? Now what is area under the curve? Well, basically it's is this area here. Right? This is area under the curve. And is mainly used for relative purposes, meaning to compare classifier. For example, you want to compare a k-nearest neighbor classifier with a naive Bayes classifier. The area under the curve, the bigger the better. Yeah? So